This is my last video on how to write linear equations given certain information. And in this video, we're going to focus on how do you write the equation of a line when they give you not maybe a point on the line and a slope. Those two needed pieces of information, but what if they just give you 2 points on the line? Okay. The thing here is this. We can take a look at this first example. It says write the equation of a line that passes through the points 1, 5, and 4, 2. I think that we should start just by doing this. Let's draw a picture of what we know. We know that we have 2 points on the line. We say 1 comma 5, so write 1, 1, 2, 3, 4, 5, up 5. And we should probably label this here. So we say this is the point 1 comma 5. And then we say 4, 2 would be right 4 up 2 would be the point right here. And I already know if I've got a line going through these two things, it seems to me that we've got a negative slope, just commenting out loud. But we say here's my line. Okay, so given this line right here, what I want to do is I want to write the equation of this down. Again, we say we could write the equation of this if I knew two things about it. We say the slope, and I know some point x, y. You'll notice in this instance, we know 2 points x, y. We have an x1, y1, we have an x2, and a y2. So we have more than enough points, but we don't yet have a slope. Now, could we find a slope? Yes, this would be very easy. We could actually just count rise over run. In this case, looks like it went down 3, right 3. So our slope in this case would be falls 3, right 3. This would be negative 1. Okay. Could I have done this by using the slope formula? Yes. And so what I want you to notice is, using the picture, it's easy to find slope. Will there be times where drawing the picture is inconvenient? Certainly there will be times. So our practice when doing things like this is, of course, if you can draw a picture, but if you have 2 points like this, you have more than enough points, but no slope. So what we need to do is we need to use the slope formula. Remember that slope formula is y2 minus y1 over x2 minus x1, or change in y over change in x. So our change in y this time is 2 minus 5 on top. So we get 2 minus 5 is negative 3. We say our change in x, we say is 4 minus 1 on bottom. So we say 4 minus 1, we get 3. And this just goes to verify what we did in the picture over there. Okay. So the last thing we want to do is this. We want to write the equation. Well, of course, we have the slope. We have m. We say m, negative 1. Do we have a point? Well, we have 2 points. So here's the thing. We need to pick one of these points. It does not matter which point on the line we pick. We just need to pick one. So in this case, we say, okay, so 1 comma 5. You know, I could say, well, then I know that x is 1 when y equals 5. Okay, and so we know that these values are available to us, and we can go plug them into the slope or slope-intercept form of the equation. So we say y equals mx plus b. If we plug in our point xy, so we say x is 1, our y value is 5, and we say our m is negative 1, we get this statement, this sentence. We say negative 1 plus b is equal to 5. So b, what this implies is that b is equal to 6. Okay, so we say now we know b, we know that m is negative 1. Let's write the equation of this. So we say the line, the equation of the line would just be this. We'd say negative 1 is our m, and slope is 6. And if we look over here on the graph, you know, this obviously looks like it hits at a y value of 6 up here. So I guess, you know, and I do want to confront one thing, and I get people that ask me this all the time, like, you know, they say, well, couldn't I have just looked at this graph and said that b was 6 and, the slope was negative 1, and I could have gone and filled those things out right off the bat. Say, yeah, well, if you drew a picture, you know, this is just a good reason to draw a picture because you can see everything that's going on, okay? And we had a nice, convenient y-intercept. Doesn't always happen. So we say, write the equation of the line passing through these 2 points this time. I want to do it a little bit differently this time. Before going ahead to my picture, what I want to do is recognize that because I have 2 points, I don't yet have a slope. So I get negative 2 minus 3 on top. So negative 2 minus 3 is our change in y, is 3. And we say, okay, well, I get negative 2 minus a negative 2 on bottom. Negative 2 minus a negative 2. And so we're going to get a really awkward situation here. We get negative 5 over 0. And so the first thing that's awkward about this, first of all, is that the slope is undefined. I'll even write the whole word out. It's undefined, people. Okay. And the reason why is because we're dividing by 0. But recall also that slope is rise over run. And so if this is the case, I mean, one thing we didn't do is draw a picture. I didn't want you to see the nature of these points with respect to each other. But if you notice, they have the same x values. And so when I graph both of these, we'll draw it on this one down here. We'll say it's number 2. But we say negative 2, which means go left 2, down 2. And then negative 2 up 3. This would have been our line right here. Okay, and so the thing we want to basically effectively point out here is essentially that this is the line x equals negative 2. Since it's a vertical line, recall all vertical lines have the equation x equal a number. But to write the equation of this, we can't just use the method we used on letter A up here. We had to use the method we did on letter B. So draw a picture. Should you do it? Yeah, you should always do it. Okay, so now let's take a look at this last example here. Should I draw a picture? Yeah, let's start with that, actually. We say negative 1, 1. You know, you don't get things wrong a lot. You know, if you draw a picture of it, we say 4 comma 1 instantly. You know, I mean, it's like I already see what's going on here. Of course, the one thing I'm picking on, this is a horizontal line. So for somebody that draws a picture in my class and says, you know, obviously, Mr. A, this is like y equals 1 because this is all the points containing a y value of 1. I say, well, yeah, obviously, you got the equation. But could I have done this using our method up top, which again is, you know, let's find the slope. So we say slope is change in y over change in x. And we say, okay, well, change in y is 1 minus 1 on top, and then in the basement we say 4 minus a negative 1. You know, I got to change this to a positive. So we get this. Positive, positive. Okay, it's not 11. We get 0 over 5, which is big fat 0. Okay, so anyways, could I write the equation of this now that I know m? Yeah, actually, we have m. We have a point on the graph. I'll choose 4 comma 1. If we use this method up top where we say y equals mx plus b, does this method still work? And yes, I want you to notice that plugging in a 0 right here is kind of a cool thing. We say we have x and y is 1 and x is 4. Look at this. We get 1 equals 0 plus b. So b is 1. But in other words, you know, you get a y-intercept of 1 pretty obviously because this thing kicks out. So here's the deal. We say now I know b. And I know m is 0. And I know m and b. So let's go write the equation of this. We have y equals mx plus b, where m is 0 and b is 1. And so we get this. Y equals no x's plus 1 or y equals 1, which just goes to kind of, you know, just support our evidence for y equals 1 being a horizontal line. Okay.